Okay guys, so I'm going to do a little demonstration video. This is the only time I'm going to do this for your free response questions, but I'm just doing this just so you guys can kind of see how to go through these types of problems. I'm going to go through a process that I want you guys to go through as you work through these. Now what these are is these are actual questions from old AP tests in the years before. And what I've done is I've gone through and I've picked out various questions that are relevant to what we're learning currently, and I'll assign some to you every week to practice. And you're going to go through a three-step process. The first step is to try the problem on your own. The next thing you're going to do after that, you don't have to write this, I'm writing it so you guys can visually see what I'm saying. I want you to try the problem on your own. After that, I want you to look up on YouTube the video of how to do the problem, just to make sure that you got it right. Now, could you skip trying it and go straight to the video? Yes, but you're not going to learn much by doing that. It's very important that you give yourself a chance to see something new that you've never seen before and try to take what we've learned in class and figure it out on your own, because that's what it's going to be really like on your test. You're not going to see questions you've already seen before. You're going to have to see a new idea, and you're going to learn how to think about what we've learned in a new way. So it's very important that you try it first on your own. Then go ahead and watch the video on how to do it. Now you can, and I would go ahead and make additions on here on how to actually do the problem after that. Like, go ahead and make some corrections and stuff. But then after that, I would say grade yourself. There's actually some documents that you can look up, and I'll show you how to get to those, where you can see what score you would have received for this question. Now this step is also very important because knowing how they grade you is a very big deal. I was actually very surprised when I first started looking at how they graded these tests, because the things that I thought were important turned out not to be what they thought were important. And these are the people giving the points and determining whether or not you get the college credit for this course that you signed up for. So it's very important that you understand how these people think when they grade your paper. So you want to go through this three-step process. So I'm going to do this example for you. I'm actually just going to do your first FRQ for you. And then I'm going to show you guys, as I do it, I'm going to go through this three-step process. Okay? After that, it's up to you for the rest of your FRQs for the year. So this is just an example to help you guys go through it. So let's go ahead and begin. Grass clippings are placed in a bin where they decompose. For 0 less than or equal to t less than or equal to 30, the amount of grass clippings remaining in the bin is modeled by this weird-looking equation here, where A of t is measured in pounds and t is measured in days. This is how math people talk. It's very confusing. Sorry, it's just what we do. There's a reason for it. But what this is saying is that, okay, we have two variables. We have pounds of grass, and we have time measured in days. And up here they're telling us that we're going from 0 days to 30 days. So basically we have somebody who's mowing lawns, and they're throwing these grass clippings into just basically a giant trash can for a 30-day period, an entire month. And basically what this formula does is, if you were to plug in like 5 for t, which is right there, that's t. If you were to plug in 5 for t, what this formula would tell you, A of 5, is A of 5, if you actually plugged it in, would tell you how many pounds of grass are in the trash can at that point. So notice what I just did here at first. I sat here and I read the introduction to the problem, and I tried my best to understand what's going on there. I also, highlighted the important information, okay? You don't have to actually do that. It takes time to do that, and this is a timed test when you take your regular AP exam, so you don't want to waste too much time. But it's a nice way just to guide your thinking. So there you go. So I now know what I'm looking at. I'm looking at a formula that tells me how much grass is in a trash can after a certain number of days. And guys, that's really important. That's How are you going to get through life if you don't know how many pounds of grass are in your trash can on a given day? Okay, I don't know why mathematicians come up with weird stuff like this, but we do. So there it is. Let's go ahead and begin the problem. It says, find the average rate of change. Uh-oh, that sounds really familiar. Over the time interval 0 to 30, indicate the units of measure. Okay, so let's go ahead and analyze it. So what is an average rate of change? Average rate of change is a slope of the secant line. Okay, and a secant line is a line that touches your curve. That's my curve. That's my graph, my function. It's a line that touches your curve at 2 points. What 2 points? 0 and 30. So in other words, they want to know how much grass was in the trash can at the beginning, at day 0, how much grass was in the trash can on day 30, and then we're going to calculate the slope for that. So the slope formula, as you guys know, is y2 minus y1 over x2 minus x1. Okay, this is how you find an average rate of change. Now, I'm going to ask that you guys not write this on your paper. You could write before this, that would be okay. But let me tell you a few issues here. First of all, I'm doing this as a teaching method because I'm lazy and I don't want to waste time writing out the word average rate of change. Okay, if you write AROC on your paper, people reading your paper are not going to know what you're talking about. That's just me abbreviating average rate of change for you guys so that I don't have to write the entire phrase out over and over again. So don't write things on your paper that everybody is not going to understand. So AROC is not an official math symbol, so we're not going to write that. Okay, I'm just writing it for you to see what I'm saying. Now, you could write this. That would be fine. What are our x values that we're dealing with here? Our inputs. Well, the x's in this case are t values. So it's going to be time 2 is 30, time 1 is 0. Now you might be wondering, Mr. Bailey, how did you know that the t is the x and the y is, well, what is the y? You may be wondering. Well, usually, don't we write functions like this, you guys? That should look kind of familiar, right? Well, what do we have, though? We don't have f, x, and y. What we have is a, t, and nothing. Okay. I guess you could say that a of t is your y if you wanted to, but we don't really have a y. But in this case, y equals this, right? So what that means is that my y values, the output, are going to be this. So what's the y value when t equals 30? And what's the y value when t equals 0? So we have our y2 minus y1 over x2 minus x1. Okay? And then we get to figure that out and calculate it. So finding an average rate of change is done by plugging in your 2t values into your function and then doing your slope formula. That's how you do an average rate of change. It's the slope of a secant line. Now, here's all that you would really need to have on your AP exam. I just know this from experience. In the box here, they're gonna. I already know how they grade. I'm still gonna look up how they grade to show you guys, but I guarantee you they would want to see this little formula right here. So that's showing them that you know how to calculate the average rate of change. But that's not going to be good enough. They want to actually get an answer from you. Now you'll notice at the top here that this is a calculator active problem. That doesn't mean you have to use a calculator. It just means that you can. But just so you guys know, when they give you a butt ugly equation that looks like this, for instance, they want you to use a calculator. You know, that's not something you want to sit and do by hand, right? you want to use a calculator for that. So I'm going to show you guys how you can use the calculator to plug in these numbers. Now you could do it by hand, not by hand, I mean, but you could just do it kind of like old school style, but I'm going to show you some tricks on the calculator. And these tricks will make things go a lot faster for you if you know them, okay? So first of all, if you guys wanted to plug in 30 into this function here, right? Now you wouldn't be wrong to do this. So I'm going to show you what most of you probably would do. And you could do this. It's just that it takes a long time. And remember, these tests are timed. So and then our power button, and then you would plug in 30, right? Now, if you don't know how to make a power button on your calculator, because we need that 30 to go there as a power, the power button is right here. Now, I know a lot of you guys probably would have entered it like that, and pushed enter, and that would be fine. You could totally do that. But I want to show you guys a better way to do these problems than that, okay? It's going to seem like extra work to you in a way, but trust me, in the long run, it's actually going to make things go a lot faster. So what you're going to do is, on your calculators, which I hope you guys have one by now, you're going to push y equals. You get rid of all these old equations that are in there. And you're going to type in the function that they give you. Okay? So I want to type in this function where it says y1. So I'm going to type it 6.687 parentheses 0.931 parentheses, and then my little power button, because I need it to be the power of t. So there's the power button. Now there is a t variable, but on our calculator we're going to use x. Okay, so we're just going to push this button. That. So there's my function all entered nice and pretty. Now I want you guys to notice that that thing has been entered as y1. Okay, so on our problem here, they're calling that function a, but our calculator is going to call that function y1. All right, and that's something to keep in mind. Now what you're going to do is you're going to come out of there. Go ahead and push second and quit. Come on out of there. Now, I want to figure out what is a of 30 minus a of 0. So let's do that. Now, instead of typing in the whole thing again, watch what I can do here. I can just bring up the variable y1. So let's push variable, which is right here. You're going to push variable. You're going to scroll over to where it says y vars. You're going to push 1 for functions. You're going to push 1 again. Now, I know this is, once again, you guys are probably thinking, oh my god, there's just so much extra work. I'm just going to do it the way I want to. Trust me, we're going to do this so much this year, it's going to become like second nature to you eventually. And when it does, you'll be thankful because it's going to make things go a lot faster. So there's y1. And now, instead of a, we're using y1, right? So a of 30. So what I'm going to do is on my calculator, I'm going to put y1 and then parentheses next to it, parentheses 30. So that's a of 30 minus, and then let's bring back the y1. So vars, y vars, y1, and 0. So now we have a of 30 minus a of 0. Enter. There's my answer for the top. And on the bottom, 30 minus 0 is 30, right? So now I just need to divide this answer by 30. Now, on my paper, I wrote this, right? But on my screen, I have this. Don't lose that number. We want to keep that. This is okay to write, but at this point, you wouldn't want to stop and clear your calculator and type negative 5.904 because this is more precise. And every time you round, you lose accuracy. Okay? So what we're going to do now is we're just going to push, since my answer is still there, we're going to push divided by 30 and equals. And there's my answer. Now in AP Calculus for FRQs, for response questions, they always round to the number that is the third number after the decimal, the thousandths place. So since the number before it, 8, is 5 or greater, we're going to bump that 6 up to a 7. So the answer is negative 0.197. Now we're not technically done here, okay? So with this particular question. Let me clean up my board space a little bit. Why are we not done yet? Well, because it's in our problem, we got to make sure we answer everything we did. They're asking for it. They want us to find the average rate of change. We did that. The average rate of change is negative 0.197 on this interval, so that's taken care of. But they want us to say the units of measure. In other words, what are we talking about here? What does this number mean? Well, what does A represent again? In the word problem, A is measured in pounds. So the top of this fraction is pounds. The bottom numbers, 30 and 0, those are days. And so my answer is negative 0.197 pounds per day. So what this means is that we have grass in a trash can, and it's decreasing, because it's negative, it's decreasing at a rate of 0.197 pounds every day. Why would that happen? Well, maybe because it's decomposing or something. I don't know, but there it is. So now I've got everything answered that they asked for. I found my slope of the secant line, which is negative 0.197, the average rate of change, and I put the units of measure, pounds per day. Okay? So there's that. Now at this point, and hopefully these things won't take you this long, you guys. I'm just doing this to kind of show you how to do the problems. Matter of fact, as you guys get really good at this, you're going to find that that problem would have taken you about 2 minutes once you really get used to it. So now what you're going to do is you're going to go ahead and you're going to go into YouTube. And what you're going to do at this point is you're going to type in the particular FRQ that was assigned. So in this case, you guys can see at the top here it says 2014. So what we're going to do is we're going to, in YouTube, we're going to type Calculus AB 2014 FRQ. Okay, and then you're going to type what number it is. This was FRQ question number 1. Okay. Now we're only doing parts A and B. This FRQ had a few different parts to it, but we're only doing parts A and B for this FRQ. So when you're watching the video, you don't have to watch the whole thing. Just watch the parts that you care about. So here it is. You would click on this.
I had this problem number 1 from the
and just kind of watch it and see how these people go through and solve it to check your work. So this is how you're going to check your work, and this is also how you're going to learn how to do the problem. Okay? Whenever you're done, you've finished the problem, you've made your corrections. The next thing I want you to do is I want you guys to go ahead and go onto Google and type the same thing that we typed in YouTube, calculus but this time I want you guys to type score response, or scoring guidelines is what it is. Scoring guidelines. Okay, so if you type in scoring guidelines after that, you can click on it, and what you're going to see is this is the entire question here, and what you're going to see is how they grade it. So this is worth only 1 point out of 9. The answer, so negative 0.196 with the units. So you only get 1 point for the whole thing, which surprises me. I would have thought they would have given it 2 points. 1 point for the answer, 1 point for the units, but they didn't. So now I'm kind of learning how they grade here, okay? So what I would do at this point then is I'm going to come back and I'm going to give myself a score. I did get both of those things right, so I would give myself a score of 1, okay? And I don't want you guys to think that this is the score I'm going to give you. This is graded like homework, okay? So if you show your work and you put the score that you would have gotten, I'm going to give you full credit for the problem. So I don't want you to think that this is the score I'm going to give you. It's not. This is completely based on effort. So let's say you did this FRQ worksheet, you checked your work, and you actually got every one of them wrong, you got zeros all the way across. Well, if you filled in every box with the best of your effort and then you scored yourself, you're going to get full credit for this homework assignment. Now, it won't be like that on the day of the test, so you want to make sure that you actually know how to do these problems ultimately. But the point of this is just practice, okay? So I don't want you to think that where it says my score, that's the score I'm going to give you. It's not. It's just I want to see that you guys actually looked up how you would have been scored on this problem and that you're learning how you would be scored, okay? So hopefully that takes away some nervousness from you on this. Then we're going to repeat that for the second part of this question. Okay? The second part says, find the value. Now, at this point, I'm just doing it again because I'm going to do the whole problem with you guys, partially because I really just want to show you guys how to use the calculator. But so now you guys have the idea. So before I start part B, I just want to reiterate. Try the problem on your own. Look up the video. Check out the scoring guideline and grade yourself. Okay, that's your 3-step process I want you guys to go through in solving this. All those are important. This first step helps you know, helps you figure out how to do the problem on your own. This is how you check to see if you're right. This is how you know how you would have been graded. So all those are important in preparing you guys for this exam. Okay? So, let's go ahead and once again, I know what students can do, you guys. I know, like, I hate to give you guys an idea that you don't already have, but I know you guys can just look up the scoring guide, copy this down exactly, give yourself your score, and be done in like 5 seconds. You're not going to learn a thing if you do that, and it's fine. I'll give you full credit for the assignment, but you're not going to pass your AP exam. You're not going to pass my tests either. So you want to make sure that you actually know how to do these things, and you're not just kind of wiggling through them, taking the easy path. Because my tests will be just as hard as these, and I want you to make sure you're ready for them. Okay. If you want, you don't have to watch the rest of this. You can try the rest on your own. But I'm also going to do part B this time, just because I want you guys to see how to do this on a calculator if you haven't already done it or haven't already learned it. Okay. So what this one is, says find the value of a prime of 15, and using the correct units, interpret the meaning of the value in the context of the problem. Now here's one of the benefits of the calculator thing I told you about earlier. I've already got that function in my calculator because I typed it in there earlier. I've already got a in my calculator stored as y1. So you don't write this on your paper, but they're asking for a prime of 15, right? Well, on my calculator, that's going to be the same thing as y1 prime of 15. So we need to do this on our calculator to find this, all right? So let's do that. We're going to go to math, and we're going to scroll down until we see this thing here that says in derivative, and you're going to go ahead and type in how to find the derivative. Now, I have a really ghetto-looking calculator. I hate these ones, but this is just how this one happens to look. If you have typed this and your calculator says this too, then you can follow my steps. If yours doesn't look like that, then I'll show you how to type it in yours as well. But for this particular calculator, what you're going to do is you're going to, first of all, you're going to put the function in there, so the y1. So you're going to push bars, go over to y bars, 1 and 1. There's y1. Then you're going to push comma. Then you're going to type x. You have to type x because the problem needs to know what your input variable is. then you're going to push a comma, and then you're going to push the number that you're trying to find the derivative at, which in this case is 15. So we're going to type 15. Enter. And there it is. Now, some of you guys might be feeling really overwhelmed by it, like, man, Mr. Bay, you're showing me a lot of stuff. Right? I know I am, but trust me, you're going to get used to it. It's going to take some time. If you just stick with me and keep rolling with me, we'll get you there, I promise. All right? So, that's my answer, so I'm going to write that really quick. A prime of 15 is equal to negative 0.164. Now, we're not done yet with that answer, but before we go any further, for those of you guys that have nicer calculators, like the screen looks a little bit better, I believe yours would have looked something like this after you pushed the derivative button. If I'm not mistaken. And so you need to type x here. That's kind of like me putting my x here. Okay? You need to put the function that you're working with here. That's like me putting mine here. And then the number you're entering for the derivative goes here. That's what I put here. Okay? So some calculator screens will look like this. Some will look like this. I really like the ones over here better, but we can't always get what we want. So I'll show you both for the time being. Anyway, we're not done with the problem though. Let's read it again and make sure we have everything that it's asking for. Okay? It says, find the value of a prime of 15 and tell us the correct units. Well, the only difference between this problem and this problem is this is an average rate of change and this is an instantaneous rate of change. But they're both rates of change. So since this one had units of pounds per day, so does this one. They have the same units. So we got that and we got that. But they also want us to interpret the meaning of this value in the context of the problem. Now, once again, I'm going to give you a lot of information here, but bear with me. It's going to seem like a lot, but over time you're going to get really used to me saying this because you're going to hear me say it repeatedly, especially later in the year. When it comes to interpretations, when they ask you to interpret, you have to include three things. You need the unit of the input. You need the unit of the output. And you need the context. The unit of my input is days. The output is pounds per day. The context is we're talking about grass in a trash can, right? So, what's my interpretation of this statement? Here it is. The grass in the trash can is decaying or decreasing at a rate of 0.164 pounds per day on day 15. So notice I said all three of those things. The grass in the trash can is decaying at a rate of negative 0.164 pounds per day on the 15th day. Okay? So I had all three of those in there, and I'm going to go ahead and write that out. So I don't have to scroll down. I'm going to write it up here, but you guys would write it down here in box B. So the grass is decreasing at a rate of 0.164 pounds per day on day 15. Okay? Now you'll notice that I didn't put negative 0.164. And the reason I didn't put that is because I put decreasing. That is my negative. Now, you could have said it a little bit differently. You could have said the grass is changing at a rate of negative 0.164 pounds per day. But you can also say the grass is decreasing at a rate of 0.164 pounds per day. But anyway, there you guys have it. So we've learned a lot. I showed you guys some stuff about how to use a calculator. I showed you guys how to do FRQs, the three-step process. Do it yourself, watch the video, look up the answer key. I've also shown you guys how to do interpretations. We've talked about, specifically for the math, we've talked about two things. This problem was average rate of change, instantaneous rate of change, and units. So this was a lesson chock full of information for you guys. Hopefully it's helpful to you. And no, I'm in the long run, these should not take you that long. The more time you put in, though, the better you're going to do. And just for fun, really quick, I'll grade myself. Let me go back to the scoring guide here. I want to see what I got. Here it is, negative 0.164. The amount of grass clippings in the bin is decreasing at a rate of 0.164 pounds per day at t equals 15 days. And for this one, you would get 1 point for just getting the number right, negative 0.164, and another point for the interpretation, this little sentence right here. And so I would have gotten 2 points. Okay, so that's that. Hopefully that was helpful to you guys. The rest of the FRQs are up to you guys to do. We'll see you guys next time.